Hello everyone, my name is Stephen Mutimba, a climate change expert working with C&E Advisory. I'll take you through a fast-track electronic tutorial course on application of climate information and services in decision-making developed by the African Climate Policy Center, ACPC, of the United Nations Economic Commission for Africa. As you are aware, the African continent is exposed to vagaries of weather and climate extremes manifested as drought and floods, thus threatening livelihoods and economic development. To effectively fight climate change, there's need for better understanding and application of climate information and services because it can save lives, contain losses, increase productivity, and reduce risks. Climate information is therefore crucial in adaptation planning and climate-proofing future investments in Africa such as roads, bridges, and houses. The e-learning tutorial course on climate information is one of the arsenal against climate change, as it will inform a wider audience with the intention of building up a critical mass of people to join in the fight for survival of our Mother Earth. The e-learning course on application of climate information is divided into 4 simple learning steps. Step 1 defines climate information and services. Step 2 identifies the users of climate information and services. Step 3 discusses the role of legislation in strengthening climate information and services. And finally, Step 4 provides example of instruments available to legislators and government decision makers for mainstreaming climate information and services into development. The e-tutorial starts by providing definition of common terms used in climate change. For instance, number 1, weather is the day-to-day variation in the climate parameter. Number 2, climate is the average weather conditions taken over a period of not less than 30 years in a given location. 3, climate variability is the year-to-year fluctuations of the variation in mean state of climate on all spatial and temporal scales. And finally, 4, climate change refers to a change in the state of the climate that persists for an extended period, typically 30 years or longer, and it may be due to natural or anthropogenic causes. The module has characterized climate information into 3 types: basic, intermediate, and advanced. We start with basic climate information. Basic climate information provides climate data for selected region representing simple climate variables such as mean temperature and precipitation over different regions and timescales. Intermediate climate information is more sophisticated product and represents longer-term trends, say 2030, 2050, 2070, 2100, analyzing changes in rainfall, air temperature, soil moisture, evapotranspiration, and it's used for environmental monitoring, particularly for drought and floods and adaptation planning. Advanced climate information is more sophisticated and detailed analysis of future climate changes. It estimates changes in extreme events tailored specifically to user needs. It's used in evaluating adaptation measures and research and development. Depending on the complexity, climate information can be used for various reasons. The first one, it can be used in defining the nature and magnitude of climate risks and evaluation of adaptation options and longer-term investments. 2, climate information can be used in designing climate-proof sector development plans and maximize opportunities from predicted climate variability for different sectors. 3, it can make informed decisions about ways to reduce vulnerabilities and impacts of climate-related disasters such as floods and wildfires. 4, it can analyze the implication of climate risks for decision on long-term prospects such as infrastructure investments or insurance schemes. The e-tutorial has also information on how climate information is collected, assessed, packaged, and disseminated to end users as 3 types of climate products. These products are, the first one is forecast, the second one is climate models, and the third one is climate scenarios. I'll take you through the 3 of them. Forecasts are predictions of the weather which can be accurate up to 7 days in advance. A climate prediction or climate forecast generally on a seasonal or interannual long-term timescale. Forecasts are mostly used on a daily basis and in a predicted rains for farmers. Climate models are mathematical formulations simulating climate system processes. And finally, climate scenarios are plausible and simplified representations of the future climate constructed from climate simulation. Climate information is normally produced for differentiated need of the end users. We have individuals, communities, private sector, and government organizations have different needs when it comes to climate information. The local communities require climate information relevant for their main economic activities. For example, areas where agriculture is the main income-generating activity, seasonal forecast as well as timely information about excessive rainfall and drought can have significant impacts for farmers' productivity and safety. Private sectors needs a tailored weather information to protect resources and make climate-smart business decisions. For example, wind outlook data for allocation can assist entrepreneurs investing in wind energy. On the other hand, policymakers, government ministries, and agencies, climate information are essential in making informed and appropriate decisions on adaptation, risk reduction, and development actions. For instance, when drafting long-term national, regional, or sectoral development strategies, policymakers need to know the large-scale description of current and future climate variable trends that can affect their long-term plans. There are many ways of communicating climate information, but the common methods of communicating climate information include the traditional media channels such as television, radio, and newspaper broadcasts. We also have information bulletins, which contain detailed information and analysis of weather forecasts. Then these days, internet, email, websites, and social media are also transmitting climate information. Public displays and social forums, such as billboards, community organizations, and barazas are also used for climate information. Text messages services such as paid services, such as SMS, free messaging services such as WhatsApp are also being used to transmit climate information. And then we have on demand, which is the provision of information upon request by clients. For climate information to be of use, it needs to respond to specific needs of users, e.g. decision makers, communities, vulnerable population, and risks. It also needs to be downscaled to draw effective localized conclusion to plan, identify uncertainties, opportunities, and barriers. It also needs to be accurate to clearly define risks to be accommodated. Climate information needs to be accessible, easy to find and interpret by users, and it should have been collected over a long period of time, which is called historic trend, and frequently updated. Finally, climate information needs to be cost-effective since there are limited resources to manage information systems. The e-learning module further discusses climate information infrastructure. Collecting weather and climate data requires a functioning network of international, national, and local weather information infrastructure. Unfortunately, few countries in sub-Saharan Africa have made adequate investments in climate information infrastructure. As a result, most equipment is old, obsolete, damaged, missing, or destroyed. observation stations do not cover enough areas to generate enough accurate data in a timely manner to inform decision making. This is mainly because of underinvestment in national and local weather stations, which results in poor and often obsolete physical infrastructure. Climate data and models require highly skilled technical personnel, but many countries find it difficult to attract and retain such human resources due to limited resources. Many countries also lack capacity to follow systematic processes for climate information packaging, translating, and dissemination. The module goes further and gives tips on how to solve the above issues. It says that it's vital for Africa governments to increase budgetary allocations to national meteorological and hydrological services to facilitate quality climate information that will aid in socioeconomic planning and development. We also need investment to integrate climate information in national development. The module goes ahead and gives tips on how to solve the above problems. It says that it's vital for Africa governments to increase budgetary allocation to national meteorological and hydrological services to facilitate quality climate information that will aid in socioeconomic planning and development. It also urges African governments to integrate climate information in national development programs and to climate-proof future development planning. It also notes that increasing budget for climate information can be justified by linking climate information services directly to national development goals, such as the linkage between climate information to early warning systems, linking climate information with food security, with water resource management, with health risk management, with coastal ecosystem resilience, and ensuring public-private partnership which can be used to boost investments and increase funding to climate information and services. Finally, the module concludes with effective mainstreaming of climate information in planning, which is essential for addressing climate change, mitigation, and adaptation. It's noted that this can only be achieved if national climate services providers strengthen their observation networks and enhance capacity to deliver the full range of climate services in support of sustainable development. Climate information can have positive impacts on the ground only when integrated with policy and practices. The module gives tools for ensuring mainstreaming of climate information, and I'll talk about a few of them. The first one is advocacy and awareness raising. Widespread advocacy and awareness raising about the importance of climate information and its key role in building resilience to climate change across sectors is needed, and it's emphasized. Also, the importance of investing in a new digital technology and retention of experts that ensure quality climate data is gathered, recorded, analyzed, stored, and disseminated should be made clear during such awareness and advocacy meetings. The other tool that is given for mainstreaming is enabling environments. Governments and legislators need to consider climate information as one of the key priority development areas and create conducive environment for their collection, packaging, and dissemination. There's also need to talk with donors and development partners so that they can also assist in the process by continually incentivizing and encouraging government and legislators to create an enabling environment for generation of quality climate information services. The other tool available is training, technical support, learning, and networking. There's need for continual training and technical support for the integration of climate information concerns in the development and legislation. There's also need for change in government operational practices to ensure climate information is mainstreamed in policy making, budgeting, implementation, and monitoring at national, sector, and subnational levels. Climate information and services is provided in the government and private sector should continually build their capacity through learning, experiencing, sharing, and networking. Can I say the last one again?
Yeah, maybe from B.
From B, okay. There's need for change in government operation practice to ensure climate information is mainstreamed in policy making, budgeting, implementation, and monitoring at national, sector, and subnational level. Finally, climate information and services providers in the government and private sector should continually hold their capacities through learning, experience sharing, and networking. The last one is development tools. Climate information should be tailored to the needs of legislators with guidance on issues to consider when formulating policies and budget allocation. Government institutions should ensure that climate risk and vulnerable assessments are frequently conducted on areas, sectors, communities, and individual projects, and appropriate DRR tools adopted. In addition, decision makers and climate scientists should have frequent forums where they can discuss, learn, and share experience in mainstreaming climate information. In conclusion, climate information and services have the potential to build Africa's resistance to climate change impacts. The quality, accessibility, and scale of climate information has improved over the years. Yet the gaps in terms of quality, coordination, and analysis of the information and its dissemination and communication still exists. This climate information model is therefore a timely reminder for the need for action. I hope you've enjoyed the module. If you've got any questions, any clarification, please send it to the contact below. My name is Stephen Mutimba, and thank you very much for listening.